Hello, I am Forecaster, and this video is a beginner's tutorial for BlocklyOC, which is a web application I've created. The application provides a visual block-based programming interface for OpenComputers robots. The application uses a library made by Google called Blockly, which provides the actual interface and as well as some standardized blocks. What I've done is I've taken this library and implemented it to include OpenComputers specific blocks for robots in particular. And in this video, we are going to go over the application, and I'm going to show you how to use it to program robots. And it's not going to cover actual Lua code beyond how to get it into the game. The video is split into 4 distinct parts, not including this introduction. We'll consider the introduction part 0. Part 1 is going over the interface, which includes the work area you can see before you, the categories, different types of blocks, inputs and outputs, then OC specific blocks, as well as how to generate Lua code from it, and the context menu that the interface includes. Part 2 is the beginnings of generating code. I will start with assembling a robot and installing OpenOS onto it. Then we're going to get the robot to move, as well as update code in the game. I'm going to show you a trick there. Part 3 is interacting with an inventory in the world, taking and dropping items, as well as for loops and while loops, as well as conditions. And in the final 4th part, I'm going to create a tree chopping robot using all the things we have learned in the previous parts. And like I said, this is a beginner's tutorial, so it should be fine if you are completely new to OpenComputers, and especially if you are new to programming in general, as there is no actual code in this video, like I said before. There will maybe be more videos in the future with more advanced subjects, but we will see. So let's begin. So starting off, we're going to go over the interface. And at the top, we have a bit of information. Most importantly, we have a link to the OpenComputers IRC channel and Discord channel, or Discord server. Both of these are connected to each other, so you can use either one. We also have a link to the GitHub repository for this project, where you can find all of the source code, as well as post tickets about issues or feature suggestions and things like that. Then we have the editor itself, and it mostly consists of this gridded area, which you can pan around using left click and holding and dragging, of course. Then we have the categories on the left. The first 5 are provided by Blockly. And then we have the ones that I've implemented, which are specific to OpenComputers. And the way you use this application is you open up one of the categories, and you can see that within we have what are called blocks. And they are a bit like more like puzzle pieces. If we grab this print block, we can drag it out into the programming area. And you can see it comes with a pre-attached part here, which is a bit ghostly, which looks like this piece here, which we can also attach here. And you'll notice that it has a notch on the top and a little nub on the bottom. So the pieces that have this connect vertically to form a flow. And this makes it easy to move pieces around and rearrange them. And it will also make the program look a little neater. And you also need these when using conditions and loops. And pieces that have a nub on the left side like this, they output a value. And of course, pieces that have an equivalent hole on the right side accept a value. So the print block takes a value and it simply prints it to the screen. So in this case, since it comes with a pre-attached string block, which is what this is, or text block, we can just type something in here, like this is a string. But it can also accept values from other blocks that we can't type into. So if we have a look in the robot category, we can see that we have a number of instructions related to robots. We have one called inventory size. And as you can see, this doesn't have any inputs, doesn't take a value, we can't type anything into it. This will simply return a number representing how many inventory slots the robot has currently, which depends on how many inventory upgrades it has. If it has a single inventory upgrade, it will have 16 slots. So this will return 16. And we can attach this to the print block. And if we delete these other blocks, the current program we have will simply print how many inventory slots the robot has. And if we click this Generate Lua button up here, we will get a window pop up which has the code in it. And you can see that it has included the robot API using require, because we need that, because we are using that to get the inventory size function. And then it's just passing the return value of the inventory size function to print. We're going to close that again. Now, you may have noticed that in here, a lot of these pieces have drop-downs on them and some other fields. So if we take the move instruction, or the move block, drag it out here, this block corresponds to one of 4 functions in the robot API. We have forward, back, up, and down. Each of these are an individual function that you need to call to make the robot move. So if we now click Generate Lua, we can see that it has added a call to robot forward, which would cause the robot to move 1 block forward. We change this to up, it's going to call robot up instead, which is a separate function. Then we can also have something like a checkbox. So for example, the place function has an argument that you can pass true or false to, which determines whether it should sneak place or not. So if I check that box, it's going to call robot place, It's going to pass true as the argument, telling it to sneak place it. If I uncheck that box, it's going to have no argument because the default is false. Then we also have fields that accept numbers, like the transfer to, which tries to transfer all or up to count items from the selected slot to the specified slot. So this is to move items around within the robot's inventory. And it tries to take items from the selected slot and move them into the slot that we can specify here. Now you'll notice that we can input a value here, but it also has this notch on the side. So we can input a value from a different block. So we could, for example, attach this inventory size, which would, if we have one inventory upgrade in the robot, would tell it to use slot 16, which would probably not be super useful, but could if we wanted to. And the way I've implemented these is that this input will always take precedence over this field. So whatever is written in here, if we write 199, it is still going to tell this to use this value in this instruction. Now, you'll see that count, the slot can't go below 1 because you can't have the slots start at 1 and go up. Can't have a slot that is lower than 1. So I've set a minimum value on this input. You could, of course, ignore that by using a, if we look under numbers, we have a piece that just have a number field on it, similar to this one. We could attach this here and we could pass -10. But this would probably cause an error when you try to run this code. But it would take this value over this one, even in this case. However, you'll see that the count has the default value -1. And that is because the count argument in the transfer to function in the robot API is optional, which means you don't need to include it to call this function. And if you don't pass this value, it will simply try to transfer the entire stack in the selected slot. If you pass in a value of 10, it will try to transfer up to 10 items. Of course, there could be fewer items in the stack, in which case it wouldn't be able to transfer 10, but it would transfer as many as it can. But if there are more than 10, if there are, say, 20, it will only move 10 and it will leave 10 in the slot. But like I said, if you pass -1, it will interpret that as not passing a value, and it will try to cause the function to try to pass all of the items. So if we click the generate button here, you can see that it adds a call to robot transfer to slot 1, and then it's passing Neil as the second argument, which is no value. The reason it's -1 here is because this is a number field. This is a typed field, and I can't write Neil in here, which is a limitation in the Blockly library. Could have made it a text field, but then it would be the wrong type. Finally, we're going to have a little look at this little trash can over here. Now, you can simply drag blocks to this to delete them. You can also right-click on a block and click Delete Block, or you could just select a block and press the Delete key. But if you click on this trash can, you can see that we have a list of all the blocks that we have deleted. So if a while later you change your mind, you can go back in here and you can take a block out and put it back. And it will keep its settings. So if you have blocks attached to it that were also deleted at the same time, or it has values typed into it, it will remember those values when you take it back. So we'll keep that 10 I typed in there just now. And another thing that I should note is that you can, if you right-click on a block and click the Help button here, you can, it will open a new tab to the relevant page on the OpenComputers wiki for any of the OpenComputers specific blocks. So for all the blocks in the robot category, it will open the robot API page because they are all listed. All the function calls are listed there. For the crafting upgrade, clicking Help would open the crafting upgrade component page, which just has a single function on it, and so on. So you can, and on these pages, you can read more about what the what the functions do and what they return and what values what arguments they accept and so on. And the editor has a few different functions as well. You can disable blocks, which just causes the block to become a bit transparent. And when you click Generate Lua, it will not include disabled blocks in the generation. So if I disable this print, as you can see, we have this print. This is a string up here. And if I click Generate Lua to update this, that will go away. So you can use this to quickly exclude blocks you don't want to have as part of the program at the moment. Then you can right-click them and enable them to put them back. You can also collapse blocks, which causes them to take up less space, hides all the arguments and such. Click Expand to restore them. You can also add comments, which I'm not sure what that does actually. Okay, apparently it lets you. We have a little style issue there. I need to fix that. Comment, because you can't actually see the text while you're typing it. Presuming that that is going to, yeah, so that puts a comment in the code before that block. That's interesting. Remove that. And you could also, of course, duplicate blocks, which copies the block, all the settings and attached blocks as well, if any, which can also be very useful. So that concludes this overview of the interface, and we're going to move into doing some actual programming now. So before we actually start programming, we do need a robot to program. So we're going to quickly assemble a robot that we can work with. We're going to use a tier 1 robot. So we're going to put in a tier 1 computer case. We need a screen and a keyboard to be able to interact with it. We also need a disk drive so we can insert the OpenOS installation floppy disk. We're going to put in a tier 1 CPU and RAM, a tier 1 hard drive to install OpenOS onto. We need a graphics card, otherwise the screen will not work. We also need an EEPROM with the Lua BIOS for OpenOS to work correctly. And I'm also going to put in an inventory upgrade so that the robot has some inventory slots. And I'm also going to put in a card container. The card container will let me insert cards, such as a redstone card, at a later time if I want to do that. So we're going to assemble the robot. It gets a random name. Oops, I did not mean to punch the electronics assembler, but that is fine. We're going to put the robot on this gray square here. Open up its interface. We're going to put the OpenOS disk in the disk slot here, which will not be there if you didn't put in a disk drive in it. Then we are going to boot it up. It's going to start floating, and it's going to load in OpenOS from the disk. So we're going to run the install program to install OpenOS to the hard drive. And since that is going to take a bit, we can have a look at the web application in the meantime. So, we're going to make a simple program. So we're going to have the robot move forward and then turn left. And we're going to have it do this 4 times each so that it returns back to the starting position. Like that. And then we're going to click Generate Lua. And I'm going to Control A, Control C this code. And close that for now. And coming back to the game, it's still installing. Should be done pretty soon. There it goes. Now we can reboot it. We can remove the floppy disk because it will now load OpenOS from the hard drive instead. And then we're going to edit my program, which is going to create a new file once we save it at least. Then I'm going to press the insert key to paste the code that I copied from the application. Then I'm going to hit Control S, Control W to save and close the editor. And we can now type ls to list all the files in the current directory, which is the home directory. You can see there is now a file here called my program. And I'm going to run this program by typing the name of the file and pressing enter. I'm then shortly thereafter going to press escape to close the interface. We can see the robot move. And there we go. The program ended. Well, that's all you need to get a program into the game. We're quickly going to have a look at updating this program. I'm going to show you a little trick that I've learned. So if we want it to turn right instead, it's going to go the other way. And you can see that it has updated the code from calling turn left to calling turn right instead. I'm going to copy this, and then we're going to go back into the game. Now, if I type edit my program, and I'm just going to type my and press tab to autocomplete. we can see that this file has the previous code in it. I could create a new file, but if I want to use the same one, I have two options. I could either delete the file by typing rm and then the name of the file, and then I can type edit and then the same name again to create a new file, which will then be empty. Or if I don't want to delete the file first, I can type echo. Now, echo is a program. All the command line commands are programs in OpenOS, and it will simply output whatever is passed to it as a string. So anything in between these quotation marks. So if I say echo hello, it will just print hello or output hello to the output. Now, I can pipe this output. Instead of it printing it here, I can use a greater than sign to pipe it, as it's called, somewhere else, such as to a file. So, and if I pass it an empty string, it's going to overwrite the contents of this file with the empty string. So if I point it to the program file, and if I now type ls, you can see that the program file still exists, but if I edit my program, the file is now empty. So I can now paste the new code, updated code inside of it, and then Control W to exit. And if I now type my program into the command line, press enter, the robot now runs the updated code. So, next we're going to create a bit more advanced program. Next, we are probably going to want the robot to do something a little more useful than moving around in a circle. So I moved the robot to here, and we have a chest that has a stack of logs in it. And I want to program the robot to take one log from the chest and then move it over here and put it in this chest, which is empty. And then it should return to the starting position. So we are going to pause the game. We're going to head over to the programming application. And we're going to start with the suck instruction. And we're going to tell it to take one item from the front of the robot, which is where the chest is. Then we're going to turn right, and then we're going to move forward. And I happen to know that there is 77 blocks to the next chest. So 1, 2, 3, 4, 5, 6, 7. Then we're going to turn left, and the robot will now be facing the other chest. Then we're going to drop whatever is in the selected slot, which should be one log that we picked up. Then the robot is going to turn left again, and it is then going to move 7 blocks back to the starting position. 1, 2, 3, 4, 5, 6, 7. And then it's going to turn right. We'll now be facing the source chest. Then we're going to generate the code for this. I'm going to copy that. And then we're going to go back into the game. We're going to boot up the robot. And we're going to edit my program. We're going to paste code into it. And then we're going to run it, and I'm going to close the interface, make sure I don't stand in the way of the robot. And we're going to see what it does. You can see that it picked up a log there, moves over to the other chest. It left it here. I'm going to take it again. And then it moved back to the starting position, and the program ended. Now, I could run this program 64 times, but that would be a little inconvenient, to say the least. So let's fix that using loops. So let's pause the game again and switch back to the application. So I have this routine that does what I want. It takes one log and it deposits it in the other chest, and then it returns. But I wanted to do this 64 times, and I don't want to run the program 64 times. So I'm going to take a loop, and you can see that it says repeat 10 times. Then I'm going to place it around this set of instructions. And then I can, of course, type 64 here, and it will repeat this set of instructions 64 times. Pretty straightforward. So let's have a look at the code. And you can see that in Lua, the way you write this is you have a for, and then you have the name of a variable, and then you have 1 through 64, so how many times. And for each iteration, it will assign the current number to this variable. And that is so that you can use that within the loop for something. So you could pass the value of count to something that needs it. You wanted to iterate over the slots in an inventory, for example. But we're just going to copy this. We're going to head back into the game. And then we're going to empty the file once again. And then we're going to paste this code into it. Make sure I'm out of the way. And then we're just going to run the program. And you can see that it picked up a log. Then it comes back. And then the loop restarts. And it's going to keep doing this 64 times until the this chest is empty and that chest contains 64 logs. So I've let the robot run through the entire stack. We now have 3 logs left. Didn't think it was necessary for you to have to sit through all of that. And it has almost run through the entire battery of the robot. But once it's moved the final log, it should stop here. And the program should just end. Now all 64 logs are in the destination. And then the program ends. So it ran exactly 64 times, which is quite nice. So let's take these logs for now. And we're going to turn off the robot. And we are going to head back into the application for a little bit. And so this worked great because we know exactly how many logs were in the chest when we started the program. But what if we don't know how many logs there are? What if we want the program to run to perform this routine while there are logs in the chest? Otherwise, we want the robot to wait. So we're going to need a loop. We're going to use a while loop this time. And under logic, we have a Boolean output. So repeat while true is essentially what this says. While a value is true, then do some statements. The sum statements is what is within this gap here. We can also set this to until. So while this is false, so that would be this. And if this turns true, then it would stop. But we want while true, so this should just repeat forever while the program is active. But we don't want to repeat this forever, because if we want to, we could. It would try to take an item from the chest, but even if it fails, it's still going to move over to the other chest and try to drop nothing into it and then come back. But if we want to be efficient, we want to make sure that the robot doesn't go to the other chest and try to deposit an item into it if it doesn't get an item. So with the tools that we have in this toolbox, what we can do is we can have if we go into logic, we have an if statement. And what we want to do is we want to take this off. So the robot is going to try to pick up an item from the chest in front of it. But then we want to test using the count items in slots. So then we want, in logic, we want a test. And we're going to attach that to there. Then we're going to take the output from this count function, and we're going to compare it to a number. So we're going to insert a number here. And if the count is greater than 0, then the robot is going to perform this routine. Then it's going to turn right, go over to the other chest, drop the item off, and then come back. But if the count is not greater than 0, it is just going to come back to the first bit of this while loop. Now, we probably don't need it to try to pick up an item right away again, because that is just going to run through the energy of the robot. So under utility, we have a wait instruction. So we're going to put that at the end. So if it once it's done, actually what we should do is we're going to add an else. Here. And that gives us a second gap. So if it does not pick up an item, then it's going to wait. Otherwise, it's going to be doing some other things, which will take time anyway. But we can have it wait. Let's have it wait 3 seconds. So if it fails to pick up an item, it's going to wait three seconds, and then it's going to try to pick up an item again. So now we're going to press generate Lua. You can see that we have an if statement here. And then we have an OS sleep here with a 3 in it, which means 3 seconds. And you can see that the loop says while true do. So I'm going to copy all of that. Then we're going to head back into the game. And I'm going to replace the robot again to reset its battery. Then we're going to start it back up. And I'm going to put 4 logs in here for now. And then we're going to echo blank string into my program, edit my program. I'm going to paste our code into it, and then I'm going to run it. Now, what this should do is it should take one of the logs, move over to that chest, and it should keep doing so until this chest is empty. Then the robot should sit here and wait until more logs show up. So it's doing the thing. But once it runs out of logs, we should see it stop and wait. It's now moving the last log over here. It's now waiting. And it's using a little bit of energy, but it's not using as much energy as it would have if it was still moving over here. So now I'm going to put another 2 logs into the chest. And the robot immediately, or rather after 3 seconds, starts moving them over here. So now we have 6 logs over here. And then it goes back to waiting. Now, to end this program, because we don't have any code in the program to handle a shutdown event, which is normally Control-C, I have to interrupt it with a Control-Alt-C, which forces it to crash, basically, which is what this is. But I can clear this. Now, we're once again going to pause the game and we're going to head back over into the editor. And we're going to add some print blocks to this to make it a little more verbose. So we add one before the wait instruction here, and we can type no items to move, waiting 3 seconds. And then we could also put one here and type item found moving to target chest. And we can copy this, head back over here, and then we can just press up to repeat commands we've already typed. Make it a little quicker. I'm going to paste this code into here, and then we're going to run the program again. So it says no items to move, waiting 3 seconds, and it's going to keep repeating that every 3 seconds when it performs the test. Item found, moving to target chest. Then it's going to come back and it's going to say that again as it grabs the second log. And then it's going to say no items to move again. All right. For this final part of the video, we are going to create a tree chopping program together. So I've moved our friend over here and I've given it an axe. Also given it a log, and we'll get to this later. And I've created a little station for it here. We have a charger. We have an output chest. We're not going to worry about the charge of the robot currently. What we're going to do is we're going to program this robot to check each of these trees if they are grown. If a tree is grown, it's going to move into the trunk and it's going to chop the trunk from the bottom up. Then when it runs out of trunk, it's going to come back down, move back onto the path and move on to the next tree. And then when it's checked and possibly chopped down the last tree, it's going to move all the way back to the starting position and it's going to empty the logs it's chopped into this chest. And then it's going to wait for a number of seconds, and then it's going to repeat the program. That is our concept. So let's get started. So the first thing we're going to want it to do is turn around and then move 1, 2, 3, 4 blocks to this first tree, then turn right to face this block. So let's head into the editor and get started on setting that up. So we're going to start with a while loop because we're going to want this program to repeat indefinitely until we tell it to stop. And then we are going to go into logic and we're going to grab a true piece here and put it here because we just want this to repeat. We're just not going to worry about any conditions currently. So, like I said, first step is the robot turns around. So it's just going to turn 180 degrees. And then it's going to move forward 4 times. And it will now be at the first tree. Then it's going to turn right so that it is facing the tree. Now, because the trees might not be grown yet, we want to have a check in place to make sure that the robot doesn't try to cut down a tree that isn't there. So we're going to go into logic. We're going to grab an if statement. And then if we go in the robot section, we have a compare. And if we read the description of the compare, it says, compares the block in the chosen direction with the currently selected slot. Returns true if they are the same, or false if not. And as you recall, I put a log in the first slot, which is selected by default. And this is why. So we're simply going to connect the compare to the if statement. So when it's facing the first tree, it's going to compare forward. And if the block in front of the robot is a log, which we have in slot 1, this is going to return true. It is then going to go into this bracket in the if statement. If compare returns false, which means that the block in front of the robot is not a log, it could be a sapling or air or something, or whatever, anything else, then it's going to skip this if statement and continue with the rest of the program. So in this bracket, we want to create our tree chopping code. So the first step is obviously to chop the block in front of the robot, which we now know is a log. So we're going to swing forward, which is going to break the block and collect the dropped log. Then we want to move forward into that space. And we now know that there are logs above us, but we don't necessarily know how many, because trees can grow into varying heights. Especially these oak trees that I'm using. So we want to create something that chops down logs as far as they exist, and then stops when it runs out. So we're going to grab another loop, another while loop, put it after the move. Then we're going to compare again. We're going to compare up. So while there's a log above us, we want to swing up and then move up. So we're going to break it back into the game and step through it. So robot turns around, moves 1, 2, 3, 4 blocks forward, then turns right. Then it's going to check this block at the bottom. If it is a log, it's going to break it. Then it's going to move forward into this space. Then it's going to check the block above it. If it is a log, it breaks it and then moves up. Then it's going to repeat that until the block above it is not a log. Then it's going to stop. And then it's going to, so if this returns false, this repeat while loop is going to stop, and it's going to continue at this nub here. So once it's chopped the entire trunk of the tree, we want it to come back down to the ground. So we're going to grab another while loop, put it here, and then instead of using compare, we're going to use detect. And we're going to detect down. So this says detects what is directly in front of the robot, which should actually say chosen direction, but I just copy pasted it from the wiki and didn't change it like I did with the compare, but it should say should have changed it to say in the chosen direction like this, because it depends on what you select here. But detects what is directly in what is in the chosen direction of the robot, and returns true if the robot could move through it. So it's going to detect down. While detect down is true, we want to move down. But I actually tested this, and I found that this is actually reversed. And we can test this by going back into the game. And if we open the Lua prompt and type robot detect down, we see that it returns true, and then it, as the second return value, it says solid, which means that and we know that the block below the robot is a solid wool block, which the robot cannot move into. So for some reason, the wiki description is wrong, and it's actually the reverse of that. So I don't know why that is. Might have been changed at some point, but in the current 1.12.2 Minecraft version that I'm using, it is the reverse of what the wiki says, which means that this description is also wrong. So we're going to want to change this to until, which means repeat until detect down returns true. So as long as this returns false, we can move down. As soon as it returns true, that means the block below the robot is solid, which means we're back on the ground. Let's say it saves us a little bit of time because otherwise we would have run into this problem while testing this. Once we're back on the ground, we want to move back. So the robot is going to back out onto the original path. Then we are going to turn left, but we're now going to step out of this if statement because once we have moved to the first tree, then we compare it with the log. But if it's not a log, if the tree hasn't grown yet, we want to continue on the path. So we then want to turn left back in the direction of the other trees and then continue moving forward. And we want to do that. That's the same as if we have chopped down the trees and then backed out to the path again. Then we want to turn left and then continue along the path. So this turn left is going to be outside of the if statement. Now, going back to the game, so we've chopped down this tree or not, depending on if it exists or not. Then we're going to back out to this block, then turn left. So now we need to move 1, 2, 3, 4, 5, 6, 7 blocks in this direction to the next tree. So let's do that. So we could duplicate this 7 times, but I'm not going to do that. That's very tedious. Instead, I'm going to go into loops and then grab a repeat 10 times loop. And I'm just going to type 7 in there. Then I can duplicate this and then put this here, type 4, and get rid of these. And that makes the code a lot cleaner. And I don't have to have 7 move forwards in a row. So now we are at the next tree. We're going to turn right. And then I can just duplicate this, put it here, because the tree code is the exact same. We treat each tree the same. Then I can just, after this, turn left. Then I know that there's another 7 blocks to the final tree. And then we have another one of these, like that. And then once we are done with this tree, we'll back out to the path. We're going to turn right again. Instead of turning left, because we are out of trees. So we've moved 4 blocks, check this tree. 7 blocks, check this tree. 1, 2, 3, 4, 5, 6, 7 blocks to this tree. Now instead of turning left, because no more trees, we turn right. And then we're going to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 blocks in this direction to get back to our starting position. So we're going to repeat 18 times. That would have been 18 move forwards to duplicate. Very nice and not have to do that. And we're now back at the starting position in our docking station, so to speak, next to our charger. And we now want to output the logs we have chopped into the chest. To do that, we're going to want to use the drop instruction. This causes the robot to try to output the items that are in the selected slot, either into the world or into an inventory in the direction. Since there is a chest in front of the robot now, it would try to output the items into that chest, which is what we want. And we could just put this here, and it would, so because we have slot 1 selected, it would just take all the items in slot 1 and drop them into the chest. However, we don't want it to do that, because we had a log at the start in the first slot, which we used to compare the trees, or to check if the trees have grown or not. And we need to keep that in that slot for the next cycle, because otherwise the robot will not do anything, because it wouldn't be able to compare, it wouldn't match any grown trees. So the program would basically break. So we want to make sure that it keeps one log in the first slot. Now, with the amount of trees I have, each cycle, it's not going to be able to collect an entire stack's worth of logs at a time. So we could do this fairly simply, but I'm going to do it in a way that accounts for a large number of trees, which can produce more than a stack of logs, just to show you how I would do it. So we're going to use a new type of loop. The count with loop, we're going to take this off of here for now. And at the end, we're going to put this. So count with I from 1 to 10 by 1. This is a different type of for loop in Lua, which assigns the value to a variable. And we can use this value inside of the loop. So what we want to do is we want to iterate over each inventory slot, because if we have a look at the robot's inventory, we can see that I have a single inventory upgrade in here. So we have, I think this should be 16 slots. Yeah, 4 times 4. So we have 16 slots, and currently we have the first slot is selected. When the robot breaks a block and collects it, it tries to put it in the selected slot first. If the collected item is a log, which it will be because that's what the robot is hunting, it's going to go into the slot. But if this fills up, it's going to start putting them into the next slot instead, and so on. So once this slot fills up, and this slot will still be selected, then it's going to spill over into the next slot, and it's going to start filling up the inventory, assuming it can collect that many logs before emptying it. But the drop instruction only drops the items in the selected slot. So if we have filled this up with 64 logs, any logs in any other slots will not be dropped into the chest. So we need to select each inventory slot and drop the contents into the chest individually. So that is what the what this loop is for. So we want to, now I happen to know that there are 16 slots in the inventory currently. But if we want to be a little smarter about this, we can go into the robot section and grab the inventory size piece and put it as the max value. So if we had 2 inventory upgrades, this would return 32, and so on. So instead of having to know how many slots we have, we can just use this. So this loop, once we get here, it's going to start at 1. It's going to assign this value to a variable, which we can select here. Now it automatically creates one called I, which stands for iterator. It's a common practice to do that. And if we look under the variable section here, you can see that we have a little puzzle piece now. And if you looked at here before you grab this piece, these wouldn't be here. You would just have this create variable button. But grabbing this loop piece created the I variable for us. And we can grab this, which allows us to use the value assigned to I. We can also create our own variables by using this button, but I'm not going to go over that right now. Maybe in a future video. So what we want to do, so this is going to basically iterate over each slot in the inventory. And we want to select that slot first. Now slot 1 is already selected. But we want to do this so that it selects the other slots as necessary. And then we could just put this drop forward here. And we'll leave the count at -1. It's just going to drop everything in the slot into the chest. And then it's going to go through each slot and just drop whatever it contains into the chest. And but as we established earlier, we want to keep 1 log in the first slot for the next cycle. So what we're going to do is we're going to go into logic, grab an if statement. I'm going to put this here, and I'm going to click this cog. Then I'm going to grab an else piece from this left half, and I'm going to put it here. And you can see this adds a second bracket to this if statement. Then I'm going to click the cog again to close this bubble. And now I'm going to put this select in front of the before the if statement, because we always want to select the current slot. But then we're going to go into logic. We're going to grab this comparison piece, and I'm going to duplicate I, put it here. So if I equals, then I'm going to grab a number piece, 1, then we're going to do this first bracket. Otherwise, we're going to, or else, we're going to do the second bracket. So if the slot number is not 1, we can just drop everything it contains into the chest. But if the slot number equals 1, we want to do something else. So we're going to go into numbers again, grab this arithmetic piece. Then we're going to go into robot, and we have a count piece here. We can put this here, and I could just leave this as 1 because we know that the slot is 1, but I'm going to be slightly more practical and correct. It's a good practice to do this because we might want to do this for more slots at some point, perhaps. But I'm going to take the current slot and count the amount of items in it. So if there are 32 logs in the first slot, this is going to return 32. Then I'm going to take minus and then 1. So I'm going to subtract 1 from the number of items in the first slot. And then I'm going to drop that amount, which is going to leave 1 log in the first slot always. But for all the other slots, it's just going to drop everything into the chest. And that's it. So once it's iterated through all of the slots, it reaches the end. Then we are going to go into utility, and we're going to have it wait. Takes a while for trees to grow. We're going to wait 15 seconds, quarter of a minute. You should probably have more than that if this wasn't just for demonstration. But then it's going to start over. Now, another problem that we would encounter is that once this loop has run, it's going to select the last slot and then leave that selected. So what we're going to do is we're going to add a select slot 1 to the start of the program to make sure that the first slot is always selected when the program starts. Otherwise, it would fail the comparison when trying to check if the trees are grown. So, with that, we should be able to test this. So I'm going to generate Lua. Then I'm going to Control A, Control C, all of this. Then we're going to head into the game. And we're going to exit the Lua prompt with Control C. And then we're going to edit, chop, create a new file. And then we're just going to press Insert to paste all of my code into it. Control S, Control W. And then we're just going to run this code and see what happens. The robot turns around, phases the tree, sees that it is indeed a log, chops the trunk, comes down, backs onto the path, moves to the next tree, and then just repeats. We know those blocks are all the same. There should be nothing strange there. And once it is done with that, it moves back to the start. You can see it collected 14 logs, left 1 in the first slot. Last slot is currently selected, but after 15 seconds, when the program starts, the loop starts over again, it is going to select the first slot, and then it's going to move along and check the trees again. If they aren't grown, it's going to ignore them and just move on, just like we specified. Let's make this tree grow a little quicker, so it is ready for the next cycle. So it moves back. It has nothing to drop. It's going to try anyway, but it counted the number of items in the slot, 1, then subtracted 1, got 0. So it dropped 0 items into this chest, leaving 1, just like we wanted. Now this tree has quote unquote grown completely on its own. So the robot detects it and chops it down. And then it just keeps going. Got 6 more logs from that. And now, as you can see, obviously 15 seconds is very short compared to the time it takes for trees to grow, generally, on average. Of course, it's a bit random. And I'm going to stop the program there. And that is going to conclude this video. Now, I plan on adding an advanced mode to the application in the future, and I might make a separate video on that. So until then, I will see you later.